Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM, and we're continuing with the introduction to general chemistry. Yep. And do I have to do anything else before I continue? One more thing. Just a minute. Just a minute. Paste. Just work. Just work. Come on. Don't waste my time. Don't waste my time. God damn it. Yep. Yep. So I do remember reading the periodic table yesterday. Now, it's the more important part. How can I summarize the whole thing into my tablet? You know what? I'll first write the stuff, okay? Now I just wrote I just read just just so the modern is based on the orbital, the valence electron are filled in, like the S block I believe it's 1 to 4, right? Nope, it's 1, 2. That's it? Okay, I have to remember those numbers. 1 to 2, S block. 3 to 12, P block. 13 to 18, S block. Now, P block. Three, 6, 12, 13, 14. Part of the S orbital, then what else? What else? What? It should not take this much time. Got the assignment 6, son! Just a minute. Implement the Needleman Wunsch algorithm. I do know the algorithm. With linear gap penalty as the Python function. Oh shit, it's a Python. Oh, I think Clonopin Commander is gonna have some fun. For reading the scoring matrices, you can use reading matrix.py. Just copy the function into your program or import it. An exemplary command invocation can be seen as. Okay. Mustafa Muhammad El Bedway. Damn, you're really locked in. Bro, I gotta lock in because if I don't, it ain't gonna work out. And I wouldn't say locked in. Like, I don't feel like I'm locked in. I need to lock in. But hey, Mustafa Muhammad El Bedway, I appreciate for checking out the stream. For test your program with the following pairs of amino acid sequences. Okay, for each word, choose at least two different blossoms and pan matrices. That's it. One exercise. God damn it. One exercise. Josh, you can do this. Don't lose the points. Okay, what was I writing? I had you muted. Like, the like your device was muted. Is that what you mean? You know, stuff happens, I guess. Uh, part of the S orbital. What was I thinking? S orbital. Now, what are the other distinctions about periodic table then? The atomic radius increases from top to bottom as part of the increase in principal quantum number. Well, I gotta go. Good luck, bro. Mustafa Muhammad El Bedway. I apologize for the latency and I appreciate you for checking out the stream. Take good luck, brother. Increase in principal quantum number. Which results atomic size. Now what else? Atomic radius decreases from left to right due to the increase due to the increase in what? Increase in what? Nuclear mass or not nuclear mass. Oh shit, I forgot the term. Intra force due to the increased number of protons which pull in reducing the size. Now ionization energy. It's the energy required to remove an electron, especially a valence electron, from its outermost orbital and from top to bottom. This ionization energy decrease has increased atomic radius easier easier ejection IE is for opposite for left to right. Think. What was it? Make sure start timer for 15 minutes. From left to right, atomic radius decreases. The ionization energy required will increase as smaller atomic radius means more intranuclear effect for the electron to be ejected. What was electron affinity? What was that? That was the energy. Okay. Add electrons exist, and this trend the energy top to bottom. Electron affinity, I'm gonna name it EA. EA as the atomic radius increases, less nuclear attraction to shielding effects. But from left to right, it basically EA increases as the radius is lower, higher nuclear attraction, less shielding effect. So these are what I remember. Is there anything else? Are the exceptions, and I'm Also a bit confused on how the F block I gotta get some water. Long hair is kinda annoying, not gonna lie. Your summary is mostly correct, but it needs tightening and few fixes here are valence electrons and in d orbital and minus 1d. Wait? Hmm. Hmm. Devoto did. Hi. I appreciate Devoto did for checking out the stream. I was checking out general chemistry. Oh, come on. Gotta do this again. Oh, I see why. Uh, uh, uh. 19th November. No. I deleted the file. God damn it. Makes sense. Helium is placed in P block. Atomic. This is a really good information because I was not. Okay. In the case of s orbital, it's exactly the p orbital. 2, it's exactly number. But when it comes to d orbital and f orbital, the the f orbital that has been filled up would be n minus 2 f orbital. Be beryllium to. Where is beryllium? Beryllium. 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 Ah. Uh, YouTube chat. I'm gonna refresh the chat because this part is looking pretty filled up, right? But I believe the chat the comment you placed is gonna be on the YouTube chat part in the website. So I don't think it's not gonna go away. It's just gonna vanish from my screen. Electron affinity. This trend is basically right but needs fixing. Across a period, EA becomes more negative, more favorable, less negative, less favorable. Wait, from left to right, atomic radius decreases. So down. Wait. That part is pretty fucked up. Because if you go down, the electron has uh, more radius, which results in less energy needed to put in. Oh, we got Black Friday. Okay. Nah. Your trend is basically right but needs fixing. General trend across a period, EA becomes more negative. Down a group, EA becomes less negative. EA trends are messy and have more exceptions. Noble gas have positive EA, they don't want electrons. Group 2 and group 15 have usually low affinity. What about F block with these trends? This is where your confusion is valid. The breaks periodic. The F block breaks periodic trends because F electrons are extremely poor at shielding. Nuclear charge increases sharply. Lanthanide contraction occurs. Steady radius decrease across F block. Irregular electron filling. So the F block atomic radii hardly change across the row. Oh. Ionization energy changes slowly. Electron affinity is unpredictable. Electronegativity negativity slightly increases across the lanthanides. F block does not follow the clean patterns the SNP blocks. Your understanding is solid. Mm-hmm. 15 minutes. Push up. Gotta change the live. Hey Siri, set a timer for 15 minutes. Bro, what? Why is my phone listening to me? Gotta change the live. Oh no, I'm sorry. I'm sorry if you heard something. Yep. I had a doubt on the electron affinity. Wait. Your intuition makes sense if nucleus doesn't matter, but electron affinity is controlled mainly by the nuclear attraction, okay, not space available. So here is the correct reasoning. Why your interpretation is flipped. Bigger atom, more space, easier to add an electron, but adding an electron is not about space, it's about how strongly the nucleus attracts the incoming electron. Larger atom has more shielding, weaker effective nuclear charge, weaker pull of an extra electron, so the electron is less tightly captured. So bigger the electron. Okay, this is why. Okay. Cross the period, proton number, yeah. Increases shielding barely changes. Effective nuclear charge increase strongly. The nucleus pulls extra electron more strongly. Okay. So adding an electron. Now again, let me go to this electron. Electron is a wave. To add a wave to an atom who has an existing, the nucleus has more pull to add. Okay. So let me get this straight. So smaller electron with a nuclear pull due higher number of protons. Now if we consider this as the waves electrons are. The nuclear pull as a sort of compared to larger ones. It's snowing! God damn it! Having enough electrons as the positive wave. Not exactly. That's how it's gonna respond. You're on the right track. Okay, that's. I'll take it. Think of electrons as standing waves, negative charge density. They form orbitals. The nucleus positive potential well. Yeah. Not a positive wave, but a deep well that pulls electron waves inwards. The depth of this well increases as proton number increases. Yes. Larger atoms have so much shielding that nucleus cannot strongly pull an electron. The added electron stays out far. It's barely stabilized. Without the facial hair, it feels so weird to touch my face. Beep 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 beep. So, uh, in the case of electron affinity, I got that. I kind of understood now. So these are basically the things I need to know for an intro to general chemistry as part of the periodic table. I guess that's it, right? That's it. That's basically it. Now I remember but I'm not. But my brain is not registering with the N here. Like, is it the atomic number? Or the number which only be calculated using and it's never the atomic number and it's always the shell number. Not gonna lie, the snow is it's kind of uh distracting. You can see little small pieces flying around. Atomic number only tells you how many electrons. So what n when you n is the shell number written. Shell number is calculated from atomic number. Incorrect. What? I mean, wait, wait. If you not said electron, said atom. So why not just use the and why bother the n minus ChatGPT is slow. God damn it! Which shell is the outermost? Which subshell label belongs to which shell? Well, outermost shell. This is only matters when valid shell. Why does 3D use? Yeah. Why not treat 3D as yeah? Because valence electrons. If he loses 4 electrons first. Ah. It'll lose from 4s, and if it's gaining an electron, it'll go to 3D. Wait, I thought physically or visually 4s is inside 3D and the radial node as part of the d orbital or f orbital would be the s subshell, s shell just below it, like here 3D 4s, and that 4s outer part is the It's 3. No, I should be making a video. How's my timetable? Sequence analysis, okay. I'll do sequence analysis, and next, after that, I'll be continuing with the general chemistry, and within that, I will make sure I make the video for periodic table. It's not a lot, but it's just small stuff, small details that I need to make sure I know it. YouTube. Beep, 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 peace.